Hello, everybody. So, I'm happy to be here in Amsterdam with you today. And I'm super stoked to talk to you about microfrontend architecture and how we are using it at OpenTable. I'm an engineer at OpenTable. Just for a quick check, how many of you have heard or know about OpenTable? OK, not many. So what OpenTable does, we find a seat in a restaurant to more than 20 million people every month. We're heavy based in North America, where we have headquarters in San Francisco, and we are expanding in Europe. And I work in our engineering office in London. But before we start, let's keep working and playing with our hands. I have a quick question for you. How many of you heard about microfrontends? OK, good, good. Keep it up, keep it up, keep it up. How many of you have a microfrontend architecture in production? OK, keep it up, or down. And how many of you have embedded a widget or have built a widget to be embedded in another website before in their life? OK, OK. Interesting. And this is it's where I want to start for. I want to start about what problem we are trying to solve, to kind of give a little bit understanding of the space. I will call this, referring to the widget, a one-to-many problem. And let's see why exactly. Imagine you have a single engineer or a team of developer, a single team of developer, that they need to build a widget. And they need to build the full stack for the widget. So it's maybe some API, some service for the widget, and a front end to render the functionality to interact with. And then they need to deploy this widget to many sites, mostly sites that they don't own. So what we have here is the first thing is there are a few principles that will be very important in this kind of scenario. First is we are talking about single responsibility. So it's this team, it's just responsible of the widget. They're not totally not responsible of what's going on that website, what is happening, what the website is all about. They have the full end-to-end ownership of that little part of the front end. The second one is they need to be able to deploy that widget independently. Let's imagine that you are correcting or fixing a bug. You cannot ask those 10 websites to be redeployed. You cannot do that. So it's it's very important to be able to independently deploy that part of the front end. It's also important to have something that it's easy to scale, because here maybe you have 10 websites. But if every of those 10 websites have 100,000 requests, then it's we're getting easy. It's to 1 million requests that you need to handle. And so it's you need to scale that part of your feature. Also, what is also important to understand in this scenario, that we are talking about mixed tech stack. What it means, it's maybe the part of the front end of your widget, it's built with React or Angular or Vue, or maybe just simple HTML. And the website that you are going to embed it, you don't know exactly what is going on there. There could be anything and everything. You really don't know. But is the many-to-one problem the only problem that we can think about in a similar scenario? What about a many-to-one problem? And let's try to understand what that means. So imagine that we have 3 developers. They are all separated. Or maybe we have 3 teams of engineers. They all have a different widget. And they all are owner of that part of that feature and end-to-end. But they need to deploy together on a similar website. So it's they're working together on the same app. And they need to work out some issue. First, it's again, a single responsibility. So it's each team, it's responsible of their own feature. And it's very, very concise on what that feature does. They don't have probably to know much about what the other teams are doing. They also want to deploy independently. imagine that those streams are maybe co-located differently in different offices. For example, we are OpenTable. We have an office in London. We have an office in North America. We have office in Asia. And so it's like, how do engineers work together? It's like, if I do a pull request or try to deploy in London, it's like people in San Francisco are sleeping. So how do we handle that? So independent deploy, it's also important in this case. It also we need to easy to scale. It's like maybe some features, like will get more traffic than others, like depending on what people will do on that. And also mix tech stack. Maybe the teams decided for some reason that's like for them was better to use a different tech stack. And so you need also to keep in mind about this problem. But this sounds very like microservices, right? All those 4 principles that we mentioned, but kind of like for the front end. Yeah, this sounds like microfrontend, and this is what I'm going to talk to you about today. If you want to do a step back and understand like how can we build microfrontend today, there are a couple of things that can come handy for us. One is like old iframes. Probably you work with iframes. It's like iframes have some pro and cons. So the pro, it's like the definitely sandbox. So it's like your microfrontend where you deployed it in that website is totally isolated. So it's like you're sure that's like nobody can interfere easily with that, and you're not gonna break much outside of it. The cons, it's like that. Probably is like you can do just like client-side rendering. It will enforce like a full page load every time, and it's very hard to interact with it. So it's like if you have a lot of interaction between widgets, then it's like iframes, like you need to do a lot of orchestration around that system. Second solution that maybe solves some of the part, but not all of them, could be Ajax. So it's like what we can do is like we can have like only client-side rendering. But that's still a con. So like we cannot do a server-side rendering in this case. Here, differently from iframes, we cannot sandbox it. So it's like it's way more dangerous when you're doing Ajax because we are together in the same scope with other applications running. So we can break stuff quite easily. And the good part, it's like that it's easier to interact. So it's like if we have more widgets, like the communication between widgets, just because they sit together, it's like it's easier than using iframes. But what about if we want to do server-side renderings? Like sometimes it's like could be needed. Well, there could be stuff like server-side includes, like they're very specific to some kind of like platform and framework that you can use in your infrastructure. The pro, of course, is like that you can have server-side. The con is like that they're very tied to your infrastructure, and they're not very portable apart from where they sit in your infrastructure. The client side, it can be done, but it's like a lot of orchestration at the part where you have to implement them. And so it's like, again, you sit very, very close to your origin where you need to handle with the stuff, and the deploy and the stuff like that. It can be a little bit trickier. So if there are all those solutions that like, maybe can help us achieve one benefit or another, why did we have a need for building a custom solution at OpenTable? Few things. The first one is like flexibility. And in couple of sectors. So it's like one is like server-side and client-side rendering. We need to be able to handle both. Sometimes we need to have together. So it's like, maybe some which will just do a client-side render, while some will do a server-side render. For example, a footer, we don't want to do a server-side render because it's down on the page. So maybe we want to do a client-side render when the people scroll down. But the header is the first things that come there. Maybe we just want to serve it because it contains important navigation. Then it's like also the problem that we saw at the beginning, the one-to-many and the many-to-one. We need to be able to solve both. We have like different use cases, and we need to have like flexibility to be able to handle both, individually or together. The second part, and we really believed in serverless. We have like a very full stack culture at OpenTable where we want like team to to run it and own it. And that means it's like we want like not to ask for being able to deploy something or to create a new service. We kind of like this kind of self-served world, where like, let's say that you want to create a microservice, well, you can just check in some code. If test passed, that code will be automatically put to production. It will receive traffic, and everybody can consume. And then you have like a new service app that everybody can use it without doing any operation about it. So it's like the concept of serverless that is like, it's kind of popular nowadays. We also, of course, needed to handle a mixed tech stack, because it's like on our web properties that we will see some use case later in the talk. We have different stack, different technologies, different client library, JavaScript library, different UI framework, different part of application are built with different framework. But to give you a case, it's like those were the use case where actually we started to using this and we started to shape our solution. The first one's like, it's kind of a classical story. Many of you, I guess, many companies started with a monolith application, and then you started to break it down. I will share you a little bit how we did it. We give another couple of talks also about at Web de London. So it's like you can go and check out those online that we have more details. But I will show you what we did. External widget, of course, we also have an external widget. For example, it's a very simple one that's like restaurants can embed in their web page to do reservation through our system. We also thought about transactional emails. We send millions and millions of emails every day for confirmation about booking and reservation. And we say, why we cannot like shape it in a way as kind of like a microfrontend, where we can have like those multiple widgets that gets rendered into what is an HTML email at the end. And this will allow us to do some benefits that I will show you through. And then a little bit more, and some other examples, like, for example, A/B testing, a shared JavaScript layer. I will touch slightly about those as well. Let's start with breaking the monolith. So we used to have like a .NET monolith, and what we did, we break it apart into what we call microsites. So imagine that like we have a lot of microsites that they all look the same, but they're just in charge of handling one, maximum 2 pages of the website. What that means, it's like, let's say that you click OpenTable.com, Amsterdam restaurants. What you will eat our front door router, and then you will decide, depending on the request, or which microsite sending you. Okay, you were looking for restaurants in Amsterdam. I'm going to send you to what we call the home microsite that will sell a list of restaurants in Amsterdam. You were doing a research, we will send you to the search result microsite. So those are end-to-end full stack solution that handle a very, very specific task. Why we do that? We did that. Well, first, it allows us to break the monolith and create some autonomous team. And so we assigned each of those microsites to a different team. And they could deploy all of those microsites independently. But one thing is like started to emerge when we have this. How we were going to handle the shared element. So at the moment, like we have 25 of those microsites. And we have like about 10 teams working on them. About around 50 engineers work on our web platform. And how do we do the shared parts? What I mean by shared parts, think about the header. So it's like the header is like it's exactly the same. It's all across all those 25 websites. And deploying it in 25 microsites will need to cause 25 deployed. So this is something that we didn't want. And this is like just a one-to-many kind of problem that we see there. We also had like other part. And if you think it's like a lot of the part of the website could be components. And those components could be run independently by team that own that feature end-to-end. They have the full expertise. For example, it's like the search team knows exactly what is needed for search, how to rank out the ranking. They know how to perform and improve the queries. It's like they are in charge of that feature. It's like they need to improve that feature without asking anybody, about redeploying, search result or something like that. The other part that we touched was like external widget. And this is like what I talked. So it's like it's pretty clear. I think it's like this example. It goes back to what we showed at the beginning. So let's maybe touch a little bit more about transactional emails. Well, if you look at transactional emails when you open your browser, then you can see there are some patterns. So like, and maybe some transactional emails share some patterns. So why do we have to rewrite them? And because we can alter and what we serve, then we can say, maybe we can do even A/B test in how we build our emails. Like, maybe something perform better, like convert better, like, it's get written better. And so this was like also a place where we thought that like this approach could work. The other two approaches was like one I slightly touched on A/B test, is like being able to run A/B tests very quickly on all our web properties without having like kind of like to ask anybody kind of to deal too much with it about the deploying and keeping improving this feature, and we run the test and we learn more information. The other aspect, it's like it's maybe a shared JavaScript layer. What I mean by a shared JavaScript layer, imagine there's like those 25 websites. We want to do logging of JavaScript exception in the browser. So imagine that like we can deploy code that is like simple JavaScript layer in 25 microsites, and what this will collect all the logs for all the stuff and send it back to our infrastructure. That is a case that's like very, very easily we can do that like on the full web properties that we have. We call our system OpenComponents, and it's open source under the MIT license. It's a full stack Node.js-based framework to handle Microfrontends. And I will show you a little bit what it looks like, because I think it's like now maybe you should have like a vague idea of like what the problem we are trying to solve, where it's beneficial, but what it looks like, how it's to use it. The first thing is like, let's think about components. And components, I think it's one of the most misused or most misunderstood words in our jobs. Like, components can mean anything and everything. So I want to show you what mean a component in OpenComponents words in our microfrontend architecture. Maybe you can look at it like at a kind of like a full feature, something that you want to ship and build separately, and maybe you want like your team to own it. Like, so I'm not talking about a button, let's say, or a small, very small React component, more kind of like a full-fledged feature. And if you think about it, maybe it's like your component have a backend. Maybe a backend where actually you call some other services, you do a couple of query, you put together at the end like a view model that you want to use. It's like for rendering your front end. So in this case, we can see that we have just a function. And that's like this receive some context, and it will return a model. In this case, we just return a model that's like have some information about what is the best conf. And that's about it. The models, like at the end, it's like will be used for rendering our front end. And you can think that's like we run this function every time you get a request for this component. So imagine that you get a request for the header. We run this function, we create a view model, and we can serve that back to you. So if you look about like what it will look like the front end of a component, well, this is like it's just a very, very simple React application. And what you see, it receives the model that we create like at props, and it just renders like a hello world kind of thing. So one thing is like here, it's like I think it's important because you say, wow, it's like we're talking about microfrontend, and it's like I hear the word microfrontend, but this guy is showing me backend stuff. Why is that? Well, it's like the fact that we can have both, and this is like kind of like optional. You can have components that don't have a backend part, but the fact that like you can have it, you can tightly couple the backend with the front end. So it's like when you do a deploy, those components are immutable, and you're never gonna break their contract with the backend and the front end. That it's always the problem of how you have to deal and handle that. And so now we get a little bit understanding of what a component look like. What are the main two parts? We have like some part can handle some backend for it, and we have like the part that can render the front end. But how all those things get served? How can you consume it? How can you publish? What it work? We have something that we call the registry. The registry, it's nothing more than a REST API, where you can kind of like publish and retrieve components. You can think of it similarly to the NPM registry if you're familiar with the Node or JavaScript environment, but at runtime. So while NPM module, you use it for build time while you declare it in your dependency to build your project, those are components that get fetched as microservices, so at runtime. But I think it's probably this still sounds a little bit too abstract. So why maybe don't we go a little bit in and have a demo so I can show you how the whole things will work. So let's move with the mouse. So the first things that we want to know, it's that we have a CLI tool. So CLI tool you can install, it's called OC, stands for Open Component, and you just do npm install OC, and then you have it available. And what I'm going to show you today, it's how we can run a local registry, and how can we work with it, so you get a little bit understanding of it. But so first, let's get back to what is our components. So I created already a component. And if you look in your component, what we have a package JSON. And this is a declare where we have a OC configuration. And then you can see that we have something related to the data and something related to the template. So it's in the data, we set the entry point for what is our function, serverless function. And for the template, we set what is the entry point for our front-end application. And then we can have some extra parameters. So for example, here you see that I can say, oh, it accepts an ID parameters. You have a default. He has a description. He has an example. You can tell if it's mandatory or not. And we'll show you in a minute how that it's used and what it's useful for. But you can think about it as if every component is a service, have an endpoint that you can call, you can have query parameter to call it with. And to have, where you define this, we can use it for doing some server-side validation, creating some documentation for other people to use it. And so it's it gives a little bit more understanding for other people how those components works and what they expect when you call them. If we look at the server, here we have a slightly more complex example than the very, very simple hello world that I showed you before. So it's what we are doing, we are calling a very, very fictitious get restaurant info service. And this is it get an ID, and it's going to return us some information about that restaurant, for example, the name, and if you have some available time slots. And what we do, we return a model with the restaurant name and the time slot for the view model. So that's mainly what we are doing. So we are going to call this serverless function with an ID, and then we are going to create this model. If we look at the app, here what we are doing, it's we kind of say, if we get the time slot, then we are going to render a button, so people can click and say and book for that time slot for that restaurant. Very, very simplistic way. But so you see some kind of interaction and dynamic part in the front end. So I wouldn't look at too much into it. It's what we're doing. We have this component, and for the front end, it takes a REST name and the time slot, and then you will say book the table of your REST name and show the button to save to get a table if you have time slot for that restaurants available. And then we have some style CSS. So that's mainly it. So what we can do is it's run our local registry. So when you do OC dev, then means you say, OK, OC start a dev registry for me locally. I want it to run on port 3030. And so let's see what happens when we run that. It looks for components. It finds our REST widget. It does some dependency check. And it's it packages the components. So this time, your component, it's ready for be published on the registry. It's we optimize everything, so it's it's safe and safe for usable and consumable by other people. But let's see what we have if we hit the 3030 page. So this is like a UI that's like can be hidden, and it shows all the components that are available in the registry. At the moment, it's like this local registry, apart like OC client that is just a library for orchestrating stuff. It just have our REST widget. And it's version 1. We can click about it. And so what we see here, we see that's like the available version is 1. If we will have all the version published ever, you can choose any version. And when you choose, the UI will reflect what the documentation were, where the contract was, what the API were. It's like, and even show a live preview. If you go down, we have the parameter that we saw early. So it's like you say, OK, it accepts an ID. It's a restaurant ID. The example, it's like it's 100, and the default to 00. And down, we have like a live preview of our widget. So here, it's like we say that's like, oh, no restaurants. Yes, because it defaults to ID 0. What happens if we pass an ID of 100? Well, this is like, it's just a query parameter. So we say ID equal 100. This is like, you can imagine that it's like the endpoint for your component. And we say we want the version 1.0, and we want to call it with the ID. If we refresh this, then we see that our widgets like have a find table button. That if we click, it shows the time slot available for that restaurant. So like this is like how you can kind of like interrogate and have like working with components. But you can also preview it if you want. It's like in a full page, full browser view. And like if you change some stuff live, for example, let's override the background color. As you see behind, it changed, and there's like, so it's blue. So it's like you can also kind of like develop it like very, very quickly and see how it works, both for the server part and both for the front end. But now that we have this component and we created this component, imagine that we published it on the registry. How can we integrate it in other websites? How can we add it to those many websites? So there is one thing that we need to do. It's like just establish a contract. And this is like it's the owner of the website needs to do. It's like adding a widget, a little snippet of code in his website. That's define the contract. But let's see how that could look like. So I created a website that's like, it's not mine. But imagine that like this website, what it does, it just renders some very simple HTML. I have it live here on a different port. So this is our website. It doesn't show nothing. We don't know much about it. It's probably a restaurant. And they want to add this widget to it. So the only thing that they need to do is like they need to do these two things. One is like they need to add a OC component tag. And what the OC component tag comes with, it's like the href of the endpoint of the component. We can see that we can call it with like a specific version. We respect semver, so you can say, oh, I want to lock it on major version, so I can get automatically all the versions that's like are not breaking. And I can pass the ID 100 because that's the ID of my restaurant. And so I want to configure it for my restaurant. And then the second part that we need to do, it's like just add the OC client library. This is like, it's a small less than 3K JavaScript library, and it's used for like, doing like the client-side rendering and make sure that like the widget works as expected. If we save this, and now we refresh, now we see that we are getting the widgets at runtime embedded in the website. And you see it's configured correctly because it shows the awesome restaurant. And if you find a table, it will completely function and show that like we have a time slot available to book. But this is like its full client side. So it's like, we're talking about, OK, I'm embedding something in a website. We're doing client side. How can server-side render work? Well, let me see. If we go back to the registry, and here we are in the preview, if we simply call the endpoint for our component, what we get is a server-side render of that component. And if you see it's like this React component has been server-side rendered, and we get back a response that say, OK, here we have the HTML, and it contains everything for a full server-side render React component in this case. So let's go back to the presentation. And maybe you wonder how that works. It's like it looks a little bit of magic. It's like, all the server-side rendering and all the magic, it's like for making it like so simple to work with the serverless function and everything. So one of the important part is that this come together with a CLI. So it's like you see that I was running the CLI for OC in dev mode. What happened is like that when we use the CLI, we can use it, for example, to package component. What the CLI will ask a compiler to say, hey, package this component. So that's like it's in a way that's like for me it's like it's good to put it online and publish it. It's like so, for example, making sure that's like all the JavaScript it's handled. It's like with Webpack and everything. Depending on like how your components are done, we can handle different compiler. And then you can use the CLI for publishing. So it's like where you see that's like we did OC dev, you can do OC publish and passing in a registry. And what it will happen, boom, the component is live in a couple of seconds on the registry for everybody to be consumed and traffic be served to it. The registry, how can this registry be able to do server-side rendering for components that we don't know how they are built? Well, the registry will fall back to what we call a renderer. And the renderer it's a module, if you can think as like an NPM module, that have all the ins and outs that knows, OK, I know how to render that kind of component. Give it to me, and I can give you back some HTML. And then the registry serves back the HTML. And this is like it's how kind it work. When you put those together, the compiler and the renderer, it's what we call templates in OC. And those are just two NPM modules glued together that you can publish by yourself. And these allow to encapsulate opinion on how you do your front end. So like, for example, let's say that you need to do Vue, need to do Angular. Well, you can create your own template that handle compilation and rendering with all the opinion you want. Oh, you're doing CSS module. Oh, we are doing CSS in JS in another way. Oh, we are doing these new frameworks. Like, you can just build like this little module that handle all those parts for you and hide it away from developers. So it's like a developer can just go straight, write his React application with the convention that you say. It doesn't have to deal with Webpack configuration. It doesn't have to deal with like how the CSS it's make it performant or published online, or how if you add assets like images, how those assets get published to CDN. So it's like they are all available in your component. All of this it's be handled by the CLI thanks to the template system. There is a couple of other small parts that I think it's interesting to mention. And one is like tools. What kind of tools we build that also are open source and you can kind of like use it today for working with this kind of different infrastructure? Well, one it's a Chrome extension tool. What you can see, it's like here in this little GIF video, it's like when you run it, it will see all the open components that are live on that page. And you can select a component, and you can change any of its parameter. And what it will do, it will force a re-render of that component inside the production side that you're looking with the parameter that you are passing instead. So for example, here we are changing the language to Japanese, and you see that's like now the review component is in Japanese. And so it's like also when you're locally, and when you work locally, what you can do is say, you know what, for that component, I want to switch to my local dev registry. So at that moment, you can see your dev component that you have locally running, working inside, how it will look like, and how it works like inside a production system. So it's been a long journey. It's been a few years that we've been working in the process with ups and downs. Like we learn a lot during the journey, and we are slowly getting toward a stable V1 release in the upcoming months. One thing that's like, I think it's worth mentioning, is like that this effort, it wasn't possible without the contribution of the open source community. And so I want to really to thank everybody that's like contribute to make this project what you saw today. And they are running in production. And you can see other many contributors on the page. But normally it's like, I know I sold you, oh, this is awesome. It sounds like, it solved a lot of my problem. But are there any pro and cons? What are the downsides? Like, you're just selling me the good parts here. Yes, there are some ups and downs. What are the pro and cons of having like a micro front-end architecture in place and something like OpenComponents? So flexibility. So it's like flexibility is very high, but like that means it's like developers can kind of like do a lot of stuff. So it's like, it's very hard to get alignments. Like, you maybe end up having different frameworks and different UI library loading on the same page, and this is something sub-ideal, because it's like you're having a big impact on your end user because they need to download a lot of different JavaScript framework. They might have conflict with each other. It's like it's something that maybe you want to avoid. That's like why we recently added this whole template system. The idea is like that the templates are whitelisted by the registry owner, and you can kind of like encapsulate it, how to build stuff, and not leave that decision to your developers. So it's like, you're sure that like you can optimize all the components that maybe need to run on the same page better. Velocity. What's up? Definitely velocity, it's a big plus. I think it's like if you look on Twitter, there are some of the tweets of like the first engineer that started using OpenComponents at OpenTable, and they'd say, wow, in 10 minutes I were able to have this feature in production. It's like, without asking nobody, and it's like, just publish completely independently. So velocity is very high for being it's like able to kind of like continuously deliver the part of your front end. But that means that like it's also very easy and very quick to spread bugs and maybe to break things. Testing in this kind of environment, it's different. It's like it's not the usual way that you normally do tests. So you can do a lot of unit tests. You can do some integration tests. But like end-to-end in a complex system like that can be kind of like hard to achieve. Well, the good part that we loved the most was like this kind of like coupling together the idea of a micro front end with a serverless architecture because it allows people to have a very high velocity. But if you would ask me, okay, Nick, I like it. I think it's like maybe we will need that in my company or in my project. What do you suggest will be the next step? Like, how do I start and getting a micro front-end architecture? Well, I will tell you, don't drink the Kool-Aid. It's like, maybe you don't need it. It's like, maybe just don't do it. In the sense, it's like, there is a lot of talks around micro front-ends nowadays. There is a lot of companies doing their own kind of version of micro front-ends. But you really need to think about, it's something that you really need. This is not the only way that you can solve this problem. There can be other ways. And it really depends on like how your code base is structured, how your company is structured, how your teams are structured. So like it's something that you need to think about at a higher level and not just say, wow, let's have micro front-end because it sounds cool. But if you want to investigate a little bit more, if it's something that's worth for you, then like I suggest you a couple of websites, like microfrontends.org, that have some interesting resource about it. There is like now some microfronts GitHub repo that keep tracking of video and talk and blog post about this pattern. And then there is also this great resources of microfrontends that you can use it. And last but not least, come talk to us. Here during the conference, there is both me, there is also Matteo, part of like the core team of OpenComponents. There are also some other guys from Skyscanner, like James Ferguson, that gave a talk this morning. So you can also ask, for example, how they're using it and what they're contributing it. So thank you. And if you want to download and get like the version and start running, this is like our Git. Everything is under the OpenComponents organization. So all the contributors are made admin. It's like it's a really co-own and co-work project. And feel free to drop me an email or follow me on Twitter. Thank you.